Hi, my name is Sebastian Matteau, and today I would like to show you how you can debug your Python code. So how you can find and solve the errors in your Python script. Now let's first take a few ways in which people generally debug their Python code. So what you can do, and I think that's the most powerful technique in many cases, is simply look at the exception traceback. So simply inspect the error that Python gives you when your program crashes. Right? So an exception is an error message in Python, and it's always accompanied by a traceback that allows you to follow where the error comes from step by step through your code. So in many cases, just looking at the traceback is already enough to sort of visually determine where the error comes from and solve it. What you can also do, and I think what a lot of people do, is simply use print statements or print function calls at different points in their code to print out the value of variables that are relevant, right? So that you can sort of see how an important variable evolves over the execution of your program and whether that makes sense, whether that matches what you expect. That's quite a crude and simple way to debug your code, but it can be very useful. Now, and finally, and what I want to show you here is what you can do. What you can do is use a dedicated debugger tool. Now, in Python, the standard debugging tool is called PDB, the Python debugger. PDB is, in my opinion, a little bit hard to use because it is a purely command line based interface. So what I will demonstrate here is PUDB, which is a slightly more fancy debugger that is built on top of the PDB. So it's essentially a semi-graphical shell built on top of PDB. Now you need to install PUDB separately. It's not part of the Python standard library, but you can do that quite easily with pip install PUDB, or install it from your Linux repositories, or install it with Conda. So it is quite generally available. Now, so let's take a look at the code. What do we have? Well, we have a very simple program that revolves around the float factorial function. The float factorial function is kind of a bastardized version of the normal factorial function, and the normal factorial function is defined as follows. You give the factorial of the number 3 is 3 times 2 times 1 is 6. Factorial 2 is 2 times 1 equals 2. So that is simply a very simple mathematical function that you can apply to integer numbers, right? Numbers without decimals. And by consensus, there are no negative factorials there is no factorial for negative numbers, and a factorial of 0 is also 1, right? That's how it's defined. Float factorial function is the same, but then for floating point numbers, so numbers with decimals. And for example, float factorial 1.5, according to my made up definition, is 1.5 times 0.5, right? So 1.5 times 1.5 minus 1 is 0.75 in this case. And analogously for all other floating point numbers. Now what we want to do is simply get for I in range n, so for 5 numbers, get a random floating point number in the following range, between 0 and 10. Then get a float factorial for that random number and print it out. That's all we want to do, right? So we want to get essentially 5 factorials for randomly selected numbers between 0 and 10. So as a first step, let's simply execute our script and see what happens. Python 3, so I'm running Python 3 here, but everything I'm going to do is also possible in Python 2. So I execute it up, and then we get an error, of course. The error is a little bit cryptic. It comes from a random float, that's what we see here, right? So here we're looking at a traceback, and it provides us with some information. In random float, so in this function, we get a type error because we're trying to do a subtraction with an integer, so a number, and a tuple. Okay. In this case, I would say this traceback is a little bit cryptic. It's not that easy to immediately see what's going on. So can be useful here now to invoke our debugger. So how can we use the debugger? Well, we call our Python interpreter. We can call the debugger in various ways, but this is how I do it. I say -m to indicate that we want to load a module. The module that we want to load is PUDB, the debugger. And the script that we want to execute is simply PUDB demo. So in other words, we tell Python, run this script within our debugger. If I run it, the debugger pops up. Okay, so the debugger is very nice. You see, it gives us in the main area, it gives us our script that we're debugging. And then it has a little pane with variables, a little pane with the stack. So variables would be the variables that we're going to define during the course of our experiment. The stack would be the function calls, right? How the function calls stack up. Breakpoints are points at which we want our program to pause, which I will come back to at the end of this video. And then we have a little command line thing, which is kind of like a Python interpreter, simplified Python interpreter. Now, when you launch the debugger, the experiment or the script is good to go, but it's not running yet. And we can run it in a few ways. We can step through the code by pressing the S key. So if I press S, I will execute that import random statement. And you will see that in the variables, random is now defined and it is a module. If I do it again, I will execute the n equals 5 assignment and n will start to equal 5. So that is one way in which you can step by step trace through your code. You can also press the C key and that for continue, and that will execute the code until it successfully completes, an exception occurs, or a breakpoint is encountered. So that's what I'm going to do. I press the C key up, and then of course the program crashes, right? And we get the same exception that we saw before, this type error. Okay, so far that's what we knew. So I say, okay, I have to do all the navigation here with the keyboard. It is a purely keyboard-driven utility, which is a little bit inconvenient maybe, but you will get used to it. It's still lots better than the default PDB, which is only a command line. Okay, and now we are in so-called post-mortem mode. You see that here at the top. What that means is that our program crashed, so our program is dead, but we're nevertheless allowed to inspect the state of the program as it was when it crashed, and that is very, very convenient. So where did it crash? Well, it crashed here in the random float function. And we can take a look at the variables panel and we see that the maximum value, we only have two variables here corresponding to the two arguments. Max value is 10. Okay, that's okay. Min value, on the other hand, is a tuple. What's a tuple? Well, a tuple is a collection of two elements. So, and that's where the error comes from, right? Because what we're trying to do here, if you see that here in the code, we have max value is 10 and we're trying to subtract a tuple from it, and that's not allowed, and that's why the program crashes. So okay, so the problem here is, we see now, is that min val is not an integer, it's not a number, but it's a tuple. Where does that come from? Then what I can do is press the U key for up, and then we move one step up in the stack. So if you take a look at the stack panel, I press U, and then we move up. And one step up, we're here at the point where the random float was called. And then you see what we're actually doing is calling it with random range, which is this tuple right here. Okay. Now, what we're actually doing wrong is that we're not assigning the first element of random range to minval and the second element to maxval, but rather we're assigning the entire tuple to minval, and that's where things go wrong. So what we wanted to do instead is assign, well, as I said, the first element from random range, the number 0 to minval, and the number 10 to maxval. So what we need to do is simply fix this in our code. So now we know where the error comes from, an incorrect call to random float. So I press Q and I say, okay, quit the debugger. I go back to my program. And then here we need to fix things. So I can say, okay, minval equals random range 0 and maxval equals random range 1, right? So we fix our function call. So what we can also do instead, this is correct. What I've done right here is correct, but it's also a little bit verbose. Also, if you want to basically expand a tuple like this to multiple arguments, what you can also do is use this very sweet Pythonic notation, where you put a star in front of your tuple or your list or whatever. And then the first element will go to the first argument, the second element to the second argument, etc. So that's what we want to do here. So the entire fix essentially is just adding this asterisk here, this star. Okay, I save it. Now let's run it again without the debugger. Up. Okay, our problem is solved, but we have a new problem. We have a recursion error. Maximum recursion depth. So somewhere in float factorial, we've been calling functions so often that the recursion depth has exceeded. So a recursion is basically when a function calls itself. And when you do that a lot of times, in Python the limit is about 1,000, I think. When you call when a function calls itself 1,000 times, you get a recursion error. The stack, so the number of functions calls that stack on top of each other, exceeds the maximum depth. Okay, so I know conceptually what that means, but I don't really know where this error comes from. So let's go back to the debugger. I start the debugger again. And I think now this is a good moment in which we can step through the code to see what happens. So I say s import random, okay, good, top. I define float factorial, define random float, we enter the main part, we loop, we get a random floating point number. Okay, right, random flag web is returned. So now we have a random floating point number, 1.8. With that random floating point number, we call float factorial. So we enter that function and j is 1.8. So we check is j 0 because that's our stop criterion. We stop when we encounter a 0. It's not. So what we do is we multiply j by j minus 1. So j now becomes 0.8. Is 0.8 0? No, it's not. So we subtract 1 again, up. And now j is minus 0.16. And this is where things go wrong. Our stop criterion, we want to stop now, right? Because we have a negative number and we want to stop. But because our stop criterion is that we stop on 0 and not on 0 or less than 0, we keep going. J becomes minus 1.16, etc. And ad infinitum. We keep decrementing j by 1 until we get a recursion error. So the problem here is our stop criterion, right? The problem here is that we've taken the stop criterion of j equals 0, which would work for integer numbers, but for our bastardized float factorial function, we actually want to check for 0 or less than 0. So that's what we want to do. So again, let's say quit, up, go back, and the entire fix is j is less than or equal to 0. Let's save it, up. Now if I run it, you see that it works, we've solved it, and we get 5 nice random floating point numbers with their float factorial values behind it. So now, that is very convenient. I think I would like to, before we end the video, I would like to show you one pretty important trick, which is setting breakpoints. So a breakpoint is a part of your code where you want to stop. What this means is the following. Let me demonstrate it as follows. So say that I want to, I set a breakpoint here at line 26, and I do that by pressing the B button. That means that if I now press C for continue, my program will execute until we reach that point, and then we can inspect the state at that point. So if I press C, you see that we have RF is 1.19, and now we are here. Now, and then we can, for example, use S to start stepping through the code again. S, and see how it returns the floating point number. Right? Negative, return, up, 1. And then our F will be, right? So we can use the step to step through the code from that breaking point onwards. And we can press C again to keep executing the code until we reach that breakpoint again. C, up. Now we are at that breakpoint again. And I press C again. We are at that breakpoint again. Right? You can see the RF values change here. C to breakpoint again, etc. Now, if I want to unset that breakpoint, I simply go to that line, I press B, and then I unset that breakpoint. And if I press C now again, my program will execute until it finishes successfully or until you quit. So I press C, up. Now it says your PUDB session has ended. And now no error has occurred, so it just ended successfully. And I press quit. And now I'm happy because I know A, how the PUDB debugger works, and B, my program is correct. Now, so here I've shown you a few things, right? How you can step through your code, how you can use the stack browser to go to, if you encounter an exception, how you can navigate through the stack to see at different levels in your code what the state of the program is. I've shown you how you can use breakpoints, but you can do many more things with the debugger tool, and it's really kind of an art and a skill, but it's a skill that is worth learning. So, and I should also emphasize that the debugger is not a magical way, a magic bullet for finding bugs and solving them. It is really a way to visualize your code and to inspect your code in a slightly more detail and in different ways than you would normally be able to do without a debugger. But it still requires a considerable amount of insight into your own code and It's a technique, a skill that you need to learn. But I hope that I've been able to give you at least some start of an idea of how this works. And with that, thank you for your attention and happy debugging.